Once again, a warm welcome to all of you to the Advanced Dynamics and Control Lab, Department of Mechanical Engineering, College of Engineering, Trivandrum. If you want more information regarding our facilities, the video lectures available, you may please contact through our website www.adclct.in. Thank you for taking the time to watch our video sessions. In today's video lecture, we will be showing you how to operate Ansys Workbench interface. In a previous lecture, you may have watched how to do a modal analysis using Ansys mechanical interface. In today's session, we will tell you how to model a cantilever beam in Ansys Workbench platform and perform a modal solution. Ansys Workbench is a highly versatile tool which is much more easy to operate compared to the mechanical interface. Even a person who is a beginner, who is not familiar with the concepts of FEM or the element types, can easily work through Ansys Workbench platform. This is what Ansys Workbench looks like when you open it. You can see over here, this is a project schematic window, and you can see the toolbox on the left pane. Now we will go through a simple modal analysis. Just left click on modal and place it on the standalone system. Now once you place your module on the project schematic, it opens up with a whole lot of branches. You can see engineering data, geometry, model, setup, solution, and results. You start with the engineering data. Click on the engineering data. You can right click and press edit, or you can double click it. So I'm going to edit this. Once you press the edit button, a window will pop up showing different material types and properties. If you want to create a new material, I can just delete the existing material by right clicking it and press delete. That means my material is now blank. You can click over this tab to add a new material. You can give the name. I'm going to give the name as steel. Press enter button. Once you press enter button, you can see on the left side so many properties. For the modal analysis, we require density as well as elasticity with Poisson's ratio. Click on density, double click it, and automatically that property will be added. You can also double click on isotropic elasticity since we are dealing with an isotropic material. There are other options for orthotropic elasticity as well as failure criterions for composites, and plasticity option is also there, which you can use for advanced analysis. For the time being, we'll be using basic isotropic material with density input. For the steel, we apply 7800 as a density, and the Young's modulus is input as 210 to the power 9, 210 E9 pascals. That is equivalent to 210 GPa. You have to input the Poisson's ratio since this is a 3D model which we are going to create. So you have to input the Poisson's ratio as 0.3. After completing the material input, you have to save the project from save file and click on save. When we save the project, a name is supposed to be input. Let me name as beam test. Press the save button. Once you complete the material input and save the project, just close the engineering data tab. Now you can see a tick mark, which means this input is complete and we can proceed further. Now the question mark is with the geometry. The next step is to create a 3D beam. Double click on geometry. Automatically the design modeler will open up and you can create an easy 3D model of beam using the facilities in design modeler. You can see over here, this is the work area with the tree outline. You can see XY plane. Is it explained? Y is it plane? Since we have not created anything, it is 0 parts, that is 0 bodies. Now I'm going to operate through the XY plane. Right click on XY plane and press look at. Automatically that will be aligned with the XY plane. The working plane is now aligned with the XY plane. If you want to create a cube, first you have to create a rectangle. Go to the sketching tab. Create a rectangle by clicking on the rectangle tab. After that, you can start from the origin and draw a rectangle shape. When you draw a rectangle, you need not bother about the dimensions in the beginning. You can create an arbitrary shape and later you can adjust your dimensions. In order to dimension the drawn figure, go to the Dimensions tab. Click on the General button and come back and press the line which you are interested to create dimension. Drag and again left click to add the dimension as H1. Do the same procedure for the vertical line also. Click on the line and input. That means V2 is the vertical height. If you want to modify these dimensions, come back over the details view and you can click over here and change your dimensions. For this analysis, we will be using a 30 centimeter beam with 1 by 1 square centimeter, 1 cross 1 square centimeter cross section. So I will be inputting as 30 to the power e minus 2, that is 30 centimeter with height equal to 0.01, that is 1 centimeter. Once you enable this, you can see over here that the picture is drawn very clearly, and you can see our rectangle which is of the size 30 centimeter by 1 centimeter. Now we have to input the depth direction. In the depth direction also we have 1 centimeter. So in order to get the depth dimension, go to the sketching. From sketching you go to modeling. In the modeling pane, go to the XY plane where you can see our sketch. Now the sketch is over here. Click on the sketch and then go to extrude. When you press extrude, a window will pop up asking you add material or whether to remove and all. Then you can just modify this, especially the depth. Now I set the depth to again 1 centimeter, that is 1 to the power e to the power minus 2, that is 0.01. Now once you add that thing, you can just come back to the extrude option, just right click on it and press generate. Once you press generate button, you can see that now the solid model is being developed. Now this is the beam solid model which we have developed so far. That's all about modeling. You go back to file and press the save button, save project. Once you save the project, you can just close this window and go back to our project schematic. Now the geometry is also in the tick mark. Next step is to create the model, that is a finite element model with the boundary conditions and solution. Click on the model. Then when you click on the model window will pop up. Inside the mechanical model window, the solid model which you have created in the previous step will be transferred automatically. Now, if you observe clearly, the geometry is ready, which is a solid. Then the coordinate system is ready. Next step is mesh. In order to mesh it, you can directly just mesh for the time being, or you can change the options over here. I'm just generating one mesh. Oh, this is a very coarse mesh. We have to refine it, otherwise it will not yield good results. So come back to the bottom options, go to sizing. Under sizing, you can just change the coarse mesh to fine mesh. Again, come back over here, just update the mesh. Click on generate. Now you can see the mesh has become much finer and you're getting a better sizing, element sizing and proper representation of the complete structure. Next step is to apply the boundary condition. In order to apply the boundary condition, you come back to the Modal tab, then click on the face which is to be constrained. I am just clicking on the left end. Once I click on this left face, the entire face is selected. Now we can go to supports and click on fixed support. Once the fixed support is being checked, we can see that the left end or the left face is being made a fixed support, that is degrees of freedom are arrested in that face. So that marks the end of our analysis steps. Now we have to solve and get a solution. Go to the solution plane and press on the solve button. Once you press on the solve button, you are landing up in some error which is shown over here. The error is a general failure occurred during the solution process. That is a project model solution. So the error is with the model. Now we have to get rid of that error from our we see that we have landed up in some sort of error. We have to rectify this. So we see that the error is occurring at the model side. So come back to the model. So there is some error with the geometry. There may be some error with the geometry which has to be clearly corrected. Let us go back to the model, close this window and go back to the engineering data. Under the engineering data, right click and make this material as the default solid material. Now this material which we have defined is the default solid material. Save the project. Save the project and close this window. You can update the geometry. At the same time, you can update the model. After completing the updations, double click on the model again to open up the window. Now go to the model analysis. In the model analysis, you have to set the analysis type. On the analysis type, I will be changing the number of modes to 10. I will be interested in the first 10 modes of this beam. Press 10. The other part is left as such since we are not going into a finite element analysis of complex structures, so we leave everything as such as default values. Come back to the fixed support. Now the support has to be defined. You can delete this thing by just clicking on delete. Pick one of the end. Again go to from the modal side, go to the supports and fixed support. Now this end is fixed. Come back to the solution. Since everything is okay, we can solve. Once the solution is complete, you can see the modes of the structure displayed in increasing order of natural frequency. This is a tabular representation which is shown over here. The natural frequency of the first mode is 93.226, which is repeated since the structure is having a square cross section. The same process is repeated for the higher modes except for 2466.3. You may please make a note of 2466.3 Hz because we will look into it. Now come back to the solution. You can go to solution information to get more details regarding what has happened. Come back to the solution and come back to this pane. Click on one of the frequencies and come to the 10th number. Press shift and again click to select the entire table. Right click on it and click on create mode shape results. Now once you do that, the entire mode shape results for this 10 modes is displayed over here. Come back to total deformation, right click and evaluate old results. Once the evaluation is complete, you can see the mode shapes of the structure displayed over here. This is the first mode, and you can see the animation by clicking on the play button. You can change the view and again observe what happens. If the structure goes out of the viewing area, you can press on fit. Again, you can rotate and press the play button. In order to view the next mode, you go to deformation tree. This is the next mode shape which is shown over here. Similarly, you may view each and every result. You can observe these are all bending modes of vibration. Since they occur in both the planes, it is repeated. But if you observe the other one, you come down and go to the 2466.3 Hz. You can see what happens. Now this is that mode. This is the torsional mode, and hence it is not going to be repeated in both the planes. This is the twisting mode of the cantilever beam. In this fashion, you can do a modal analysis in Ansys Workbench with very, very easy steps. Thank you very much.